This is the Z-AIB demonstration. Every once in a while, a new analytic tool changes how we solve problems. Today's research and development, manufacturing systems, and business operations involve dozens, sometimes hundreds, of interacting variables. They are nonlinear, coupled, and dynamic. Lead times for delivering products and services are significantly shorter than ever, driven by the AI industry revolution and an accelerated global supply chain. Yet, the tools we trust, statistics, DOE, modeling and simulation, and even generative AI, were never built for this level of complexity, required accuracy, or the speed of today's global industrial requirements. Meet Z-AIB, the world's first Excel-like AI analytical engine, purpose-built to conquer these industrial challenges. Designed for scientists, engineers, and business leaders, Z-AIB requires no coding, no AI expertise, and no specialized training. Thanks to its intuitive interface, you can master the platform in just a few hours. Next, let me show you how Z-AIB works. Here, we use an example that optimizes a Mercedes-Benz vehicle inspection process to minimize the inspection time through some constraints. Step 1. Click Goal. I select Optimization to minimize inspection time while maintaining X1 as a constraint. Step 2. Click Next or Project. I begin by creating a project folder locally and ensure the raw data set is in this folder. This local folder serves as your primary working directory. It securely stores your raw data, processed datasets, and all output files for reviewing, editing, saving, and copying. Next, I create a project folder on the user's private cloud server. This cloud folder is used to manage temporary files generated during AI model development. It is not intended for user review, but supports the secure and efficient execution of the AI model development process. Step 3. Click the created folder on the cloud server. I then click Choose File from Local Folder to upload the inspection dataset from the local project folder to the cloud project folder. Each row represents a single vehicle inspection process. Each column represents an inspection impact parameter, along with the target variable that is the inspection time, Y. To ensure data security and confidentiality, all impact parameters are anonymized. I click Process and Save AI Training Ready file to convert the raw dataset into an AI-ready training dataset. Next, I select the input variables and define the target variable. The target variable of this example is the inspection time. Next, I select the optimization goal as Minimize. Finally, I set X1 as a constraint, with an allowable data range between 5 and 20. At this point, I am ready to develop the AI model and identify the optimal window of the car inspection process to minimize the inspection time. Then, I click Saving all the above data and information. Step 4. Under Model Training, I click Start AI. Model Training. Z-AIB now automatically builds a deep neural network model and begins the optimization process. Depending on dataset size and model complexity, this step typically takes 15 to 30 minutes. Once the model is fully trained and the minimum inspection time is identified, the results are presented clearly. You will see the model's RMSE for both the training dataset, which represents 80% of the total data, and the testing dataset, the remaining 20%. RMSE and the optimized value of the target variable are displayed graphically, allowing you to immediately evaluate model accuracy and performance. Step 5. Click Go to the next step, to Analysis. Now we can analyze the optimized AI results. The view graph shows the measurable AI model improvement in the target variable, inspection time, over the dataset average. It identifies the top impact variables on the target variable. Through SHAP analysis, we see both the direction and magnitude of each impact variable's influence on the target variable. To help users interpret the SHAP analysis view graphs, we provide explanations and relevant examples for both SHAP mean value and SHAP value terms. The above outcomes are not just an optimal window, but they are actionable intelligence. Next, click Download Output Files and Next. Step 6. Deployment. The optimized parameters can now be implemented directly in your specific project, such as speeding up new product development, optimizing advanced manufacturing processes to reduce costs, predicting market demands for next quarter, etc. Engineers, scientists, and business leaders typically understand how to deploy the AI model outcomes because the results are intuitive and transparent. Last but not least, click Export Optimization Results to export all output files to your local folder. Let's recap the video demo. Z-AIB provides innovative AI solutions with high reliability, super fast speed, and high security to advanced technology industries due to handles hundreds of variables and captures non-linear interactions that traditional methods cannot. Deliver the reliable and actionable outcomes that generative AI cannot. No coding, no AI expertise, and no specific training required. Features an intuitive user interface that users can master in hours. Delivers substantial ROI at a low cost of entry. Z-AIB puts the power of AI directly in the hands of scientists, engineers, and business leaders,